Okay, today we're going to be talking about the area of trapezoids, kites, and rhombi. Rhombi, it's the plural for rhombus, okay? The first thing we want is to know what is the formula for the area of a trapezoid. Well, let's see where we get that from, okay? Take a look at this trapezoid right here. What if I do this? What if I take this trapezoid, copy it, so that it's exactly the same. Take this one. Let me see if I could grab it. Turn it around 180 degrees and then put it here. Notice that all of a sudden we have a parallelogram. Here we go. So we have a parallelogram, right? So the parallelogram is base times height. Base times height. Well, basically, in the trapezoid, we're going to see that the base of this parallelogram right here is basically this base. Notice this base right here. And then there is another one to continue all the way to get the whole parallelogram. Now, notice that this base right here, this one is congruent to this one because we turned it around, right? And this one right here is congruent to this one right here. Now, we're going to call this one base 1, and we're going to call this one base 2. Well, where else do you see base 2? Well, you see it here. Base 2. Now, we take that times the height. The height is perpendicular to the base. The height is perpendicular to the base. So let me grab this one, and it's perpendicular to the base. So it has to be, the height would be that, right? And remember that it has to be perpendicular. So I'm gonna denote that for perpendicular, a right angle. So this would be the height. So if I take the whole base of this parallelogram and multiply it times the height, I would have the area of this whole parallelogram. However, I want the area of this trapezoid. Well, notice this trapezoid is half of the whole parallelogram, right? So I'm gonna put that there because that's part of the formula. So notice base 1 and base 2, that would make the base of the parallelogram would be made by base 1 plus base 2. So the half of base 1 plus base 2, and then I'm gonna multiply that times the height. And the reason we want to cut it in two, because we don't want the whole parallelogram, we want half of it. So that's the area of a parallelogram. Okay, the area of a formula for area of a parallelogram, for area of a trapezoid is half times base 1 plus base 2 times the height. All right, here's an example. Here is a trapezoid, right here approximately, right? Because it doesn't go all the way here, so I would have to subtract that, but let's estimate that. So we have the height, because this is perpendicular right there. So we got 1/2. Base 1 is 511 miles plus 205 miles, and that times the height, which is 309. If we take this, we'll go to the calculator to make it easier on us. So that's 511 plus 205. 511 plus 205. Let me delete that. 205 close parentheses times 309 close parentheses, and divide that by 2. And that should give me the area approximately. That's 110,622 square miles. So this right here, it's 110,622 square miles, because we're talking about area. Let's try it. Let's go down and try these, okay? It says try it. Find the area of the trapezoid. So We need here, we have this is 42 degrees, so we got everything, and we are looking for the area, so we need the height. The height is this one that is perpendicular to the base. The base is 17, so that's base 1. This is base 2. We need the height, so how can we find the height? Well, notice we'll have 11 meters for the hypotenuse of this right triangle. This one right here is opposite to the angle. So opposite and hypotenuse, that would be the sine ratio. So the sine ratio of 42 degrees would be equal to the opposite times over the hypotenuse. Sorry, over the hypotenuse. Take that, take the 11, multiply it on both sides, right? So 11 sine of 42 degrees would give me the h, which is the height. So I'm looking for that height. So let's go to the calculator. Make sure the calculator is in degrees. It is right here, see it? So we're gonna go and say 11. Kind of sensitive. Trigonometric ratios, sine of 42. Enter. And that's 7.4. So the height is approximately 7.4. And we're gonna go with that one. So that's the height. So the area of a trapezoid, remember, it was given by 1/2 times base 1 plus base 2 times the height. So the area is equal 1/2. Base 1 is 17 meters plus 8 meters times the height. The height is 7.4. We go to the calculator and we say, well, let's start with a new page so that we're good. All right, so we say 1/2 times parentheses 17 plus 8 close parentheses times 7.4. Enter. That's 92.5. So the area of this trapezoid is approximately 92 and 5/10 square meters. Here is your answer. All right, pretty simple. Now, what happens if they give us the area and we are looking for the height? Now they gave us the area and we're looking for the height. Well, we're gonna use the same formula, right? We're gonna use that same formula. Let me give us some space here. And we're gonna say, well, the area, which is 51.1 square centimeters, it's equal to 1/2 base 1 times base 1 plus base 2, so it's 11.1 plus, let's see, what was the other one, 3.5, and that times the height, and the height is what we are looking for, right? So basically, if I take this 1/2 and multiply it by 2, because the inverse of that, right, the inverse of that is 2, so multiply by 2 on both sides so that this cancels. So remember, you're taking the inverse of this, so multiply the whole thing times 2 over 1. See? Just flip it. So times 2. That will cancel this, and it will leave me with 11.1 plus 3.5 and 2 times 51.1. So 2 times 51.1 is what? 102.2. I think. Let me see. 51.1 is, make sure, times 2. 51.1 times 2. Enter. So it's 102.2. And let's solve this one. 11.1 plus 3.5. 11.1 plus 3.5. Oops. 3.5. Enter. Is 14.6. So we have 14.6 H, and on this side we have 102.2. Okay, so now we divide by 14.6. So 102.2 divided by 14.6. So hey, in the calculator I could do this, the 102.2, enter, divided by 14.6, enter. That is 7. So the height is basically 7 because you're dividing 102.2 divided by 14.6. Okay, so here is my height. So the height equals 7 centimeters, and that's the answer. All right, now how about kites and rhombuses? It's not rhombuses, it's rhombi. I don't know why they wrote that here. It is our rhombi, kites and rhombi. Okay, so let's see, the formula for that is 1/2 diagonal 1 times diagonal 2. Remember the diagonals. Now you need to know the properties of these. We already went over it. Remember, in a kite, this side right here is congruent to this side. This diagonal cuts this diagonal in half, so the long diagonal cuts the short diagonal in half. So this is congruent to that, and this side right here is congruent to this side right here. However, these two are not congruent, so don't ever think that. On a rhombus, all sides are congruent. That's what makes it a rhombus. And the diagonals bisect each other, so that means that this is congruent to this because it's cut in half, and this one right here is congruent to this one right here. That's the rhombi. So also, these diagonals are perpendicular. That you, in both of them, the diagonals are perpendicular. As long as you know those properties, everything else will work nice and dandy. So let's go take a look at it. Okay, so far we have that the area of a parallelogram, we understood that it was base times height. Triangle is 1/2 base times height. The trapezoid equals 1/2 base 1 plus base 2 times height. And the kite and rhombus is 1/2 diagonal 1 times diagonal 2. Okay, there are your formulas. This is just a review on the formulas that we have learned so far. So here, find the area of the following. We're given a rhombus, so that know that in the rhombus all the sides are congruent. The diagonals are bisectors of each other, so therefore this one is congruent to this one right here, this half, and this half is congruent to this half. So therefore, if this is 30, this is 30, and if that is 20, this is also 20. So we have diagonal 1 equals 40 feet, diagonal 2 equals 60 feet, and the formula is area is equal 1/2 diagonal 1 times diagonal 2. Pretty simple. So it's half of 40 times 60. So you could do it either way. You could say 4 times 6, that's 240 divided by 2. You could do it that way, or you could say, well, you know, we have half of 40, that's 20. And this is 60 times 60. So 2 times 6 is 12. And we have here is what? 2 zeros, right? 2 zeros. So we have 1200, and it is in feet, so that would be 1200 square feet. Okay, so the area would be 1200 square feet for that, for this right here. Okay, next we got a kite. In a kite, remember that this side is congruent to this side, and so is this one is being bisected by the long diagonal, so therefore this is also 20 inches. Okay, so I have one of the diagonals. Diagonal 1 is 40 inches. However, diagonal 2, I only have part of it. I have 26 inches. I need to know this right here. This is a right triangle. Notice this is 32. Now, to find that, we could use the trigonometric ratios, right? Since I'm looking for this right here, I'm gonna say that is the opposite. So this is the adjacent. This one right here is the hypotenuse. So opposite and adjacent, I'm going to use the tangent ratio. So the tangent of 32 degrees is equal opposite, I'm going to put x, over 20 over adjacent, opposite over adjacent. We multiply by 20 on both sides, so 20 tangent of 32 should give me x, which is what I'm looking for right here, which is the opposite, right? There, you could go to the calculator, put it in the calculator. 20 tangent of 32 degrees, and that will give you how high is that. So it's about 12.5. So now I know this is 12.5 right here. So diagonal 2 will be 12.5 plus 26. So I'm going to put in a calculator, 26 plus 12.5. 26 plus 12.5. Enter. That's 38.5. So that diagonal 2 is 38.5. Now I'm ready to find the area. The area is given by 1/2 diagonal 1, which is 40, times diagonal 2, 38.5. So half of 40 is 20 times 38.5. So basically I could go here 20, or I could go like that, 38.5 times 20. That's 770. So the area of this kite is 770 square inches. And that's how you do that. Okay, here's another rhombus where we're going to be using the Pythagorean theorem. Okay, if this is 10 in the rhombus, remember all the sides are congruent. That's what makes it a rhombus. So this must be 10 or 10 inches. I am looking for this short leg because that way it gives me, I already know this is 8 inches here. Once I have that, just double it. So to use that, oh, they give us a hint. Use the Pythagorean theorem. Well, I'm looking for a leg. Remember to look for a leg. A is equal to the square root of c squared minus b squared. In this case, is equal to square roots. Remember that c is the hypotenuse, so 10 squared minus 8 squared. In this case, 10 squared is 100 minus 64. So we have that 100 minus 64 is what? 6. And 9 minus 6 is 3. So it's the square root of 36. So basically is 6. So that right there will be 6 inches. So this is 6 inches. So now I have my diagonal 1, which is 8 times 2, which is 16 inches. Diagonal 2, which is 12 inches. And now just find the area. 1/2 of 16 times 12. Okay, and you could put it just like that in the calculator. 0.5 times 16 times 12. Oops, times 12. Enter. So that's 96. So that is 96. The area of this one is 96 square inches. Neat. And last, we have the kite. They gave us that this is going to use special right triangle. Remember, this is perpendicular. It's 2 diagonals. So the first diagonal, I need to find this, and I also need to find this right here. So I'm going to put X right here. I'm going to put Y right here. So it's a special right triangle in a 30, 60, 90. 30, 60, 90. Remember that the short leg across is X. Across the 90 is 2X. And this would be the long leg, X square root of 3. So that's the formula right there. So If I got 10, I already know that's the hypotenuse, so the short leg will be half the hypotenuse, so that this will be 5. So y would be 5 centimeters. And if that is 5 centimeters, then that the long leg is 5 square root of 3 centimeters. So everything is done. Very good. Now all I have to do is, this is 5 square root of 3. Well, this is 5 square root of 3 as well. 5 square root of 3 plus 5 square root of 3 would be 10 square root of 3. That's one diagonal. And the other diagonal is 18 plus 5. So the other diagonal is 18 plus 5. That's 23. All right. So we have 10 square root of 3 centimeters and 23 centimeters. So go to it. So 1/2 10 square root of 3 times 23. Half of 10 is 5 square root of 3 times 23. Okay, and 23 times 5 that's 115 square root of 3. And that's square centimeters. That's the exact amount. If you want the approximation, just put that on the calculator. 115 square root of 3. So 115, very sensitive, 115 square root of 3. And that gives you, that is 199.2. So approximately 199.2 square centimeters. Great. Alrighty then, so we're done with this introduction to finding the area of rhombuses and kites and also trapezoids. So I'll see ya.